In this lesson, we will learn the stroke line cap and stroke line join properties. The stroke line cap property defines the shape of the cap, which will be used at the end of the open path when they'll be stroked. And also define the cap for the path that have a zero length. The stroke line cap property can take three different values: butt, round, and square. A butt value indicates that the ending of each subpath doesn't extend beyond the start or end point of the subpath. The round value indicates that the beginning and the end of the open subpath will be expounded by the half of the circle, whose radius is equal to the half of the stroke width. The square value indicates that the beginning and the end of the subpath will be expounded on the rectangle, with a length that is equal to the half of the stroke width, and with a width that is equal to the stroke width. If the path has zero length and the stroke line cap is set to butt, the user agent will stop rendering. The path length can be equal to 0 if the path data attribute contains only move to command. If the path length is equal to 0, but if the stroke line cap property is round or square, the result will be different. Do your homework to learn more. The stroke line join property defines the shape of the stroke that is used in the corners of the path or basic shapes. The stroke line join property accepts 5 different values. These are meter, meter clip, round, bevel, and arcs. A bevel value indicates that the bevel angle is used to join the segments of the path. A round value indicates that the rounded corner is used to join the segments of the path. The radius of the semicircle is the half of the stroke width. The bevel and round values are similar to the butt and round values of the stroke line cap property. The meter value indicates that the sharp angle is used to join the segments of the path. The angle is formed by expounding the outer edges of the stroke until they will meet. If the meter length divided by the stroke width is greater than the stroke meter limit, the segments will be joined by a bevel. Sounds a little confusing. Actually, it isn't so. You will understand how simple this subject is in a few minutes. So let's remember school geometry curriculum. All we will discuss in this lesson will be defined in the context of a right triangle. A right triangle is a triangle where one angle is equal to 90 degrees and the other two are acute. The side that is opposite to a right angle is a hypotenuse. The sides that are adjacent to a right angle are legs or catheti. The right angle is labeled by a Greek lowercase letter gamma. The two other acute angles are labeled by Greek lowercase letters alpha and beta. A side can be adjacent to an angle or opposed to an angle. For example, the side AC is the leg that is adjacent to an angle alpha, and it is opposed to an angle beta. The side BC is the leg adjacent to the angle beta, and it is opposite to the angle alpha. Thus, the alpha angle has adjacent side AC and the opposite side BC, and the angle beta has an adjacent side BC and the opposite side AC. In this lesson, we will need only one trigonometry function. The sin is a trigonometry function of the angle. The sin defined in the context of the right triangle is the ratio of the opposite leg to a hypotenuse. So we have done with geometry. Let's figure it out, how it will help us with the stroke-line join property. But before we will start, let's add the few definitions. The first definition is meter length. It's the distance from the inner edge of the stroke to the end of the meter. The second one is meter limit. It's a maximum length of the meter that is allowed by the user agent and that is expressed in the numbers of the stroke width length. If the length of the meter goes beyond the allowed value of the length, then the line join will end with a bevel. To calculate the allowed length of the meter, you should multiply the meter limit value by the value of the stroke width. You can use another strategy. You could divide the meter length by a stroke width and then compare the result with the value of the meter limit. Let's check how does it work on the example. In some abstract shape, the stroke width is equal to 100 pixels. And the meter limit is equal to 5. Then the maximum length of the meter might be equal to 500 pixels. But how do we calculate the length of the meter? We can use the knowledge of the trigonometry that we have got in this lesson. The length of the meter is the distance from the inner edge to the outer edge of the joint of the segments. The following formula is used to calculate the length of the meter. The length of the meter is the stroke width that is divided by the sin of the theta angle that is divided by 2. Let's make a closer look at this formula. We can make several conclusions. The first is that a meter is a bisector of the theta angle. The bisector is a line that divided the angle by half. That's why we use the sin of the theta angle divided by 2. The second conclusion is that the meter length is the hypotenuse of the right triangle. And the stroke width is the opposite leg of the theta angle that is divided by 2. The third conclusion, that the sin is always a ratio of the opposite leg to a hypotenuse. For example, if the theta angle is 60 degrees, then the theta angle divided by 2 is 30 degrees. The sin of the theta angle that is divided by 2 is 0.5 or 1/2. And that means that the length of the opposite leg is equal to the half of the hypotenuse. In this case, the length of the meter is equal to the stroke width times 2. To find out the length of the meter, you have to divide the stroke width by 1/2, which is the same as the stroke width multiplied by 2. We can prove this formula mathematically. The meter length is equal to the stroke width that is divided by the sin of theta angle that is divided by 2. The sin of theta angle that is divided by 2 is equal to the stroke width that is divided by the meter length. The stroke width divided by the stroke width that is divided by the meter length is equal to the stroke width multiplied by the meter length and divided by the stroke width. So let's reduce multipliers. In our case, it's a stroke width. So we get the meter length as a result. The last value of the stroke line join is arcs. And that means that the arc will be used to join the line segments. The arc's value is used to join the Bezier curves. The formula for calculating curvature and length is complicated. So I won't use it because it will transform this course to trigonometry course. If you're interested in this subject, please read the documentation. And that's all for now. Do your homework, and I will see you in the next lesson.